Hello, Algebra 2 students. It's Ms. Peltier again, back for installment number 3 of our distance learning from Alvin High School during our coronavirus sort of staycation at home. Not sure we feel like it's vacation, but that's okay. This is our third time to visit, and this one should be going out on the 27th, which would be Friday, and which would make any assignments that you choose to do 27, 29, 30, we'll say March 31st, which would be the Tuesday or Wednesday. If you got it in by Wednesday, that would be fine. Remember, I'm putting everything on an assignment in our Google Calendar. You'll have a video, you'll have the blank notes, you'll have the filled in notes, as well as a worksheet assignment if you choose to do that, or the IXL assignment that's on there as well. And at the end of the day, at the end of this lesson, I'll give you the IXL assignment as well. If you do the worksheet, you can just do your own work on your own page, or if you want to print the page off and do the work on there, make sure you do show your work, take a picture of it, you can upload it to the assignment, or you can tell me that you've already completed it and send me a message that you did it in IXL and I can find your stuff there, okay? So make sure you're doing that. If you have questions along the way, you can tune into one of our Google Hangouts. Remember, we do Google Hangouts Monday, Tuesday, Wednesday, Thursday at 9 o'clock with Mr. Cleland, 11 o'clock with myself, 1 o'clock with Miss Blatt, and 2 o'clock with Miss DeMond Brun. So you can check any of those and ask questions or just see us work problems that other students may have questions on as well. Anybody can log in. We can have up to 250 people in a Google Hangout. So when you go on, make sure you turn your microphone off so that we don't have a million people talking at once. But if you have a question, turn your mic on and you can ask your question. Okay? So we'll move on to solving, which we have solved quadratic equations before. I've given you basically your 4 steps that we do almost every time. Depending on what the problem looks like, you could have more steps involved. For instance, moving everything to one side of the equation and set it equal to 0. So sometimes there's nothing to do for that. Sometimes you might have 2 or 3 steps that it takes you to get everything situated where you want it. Then we're going to factor what's left on that side of the equation. Each of those factors, we're going to set those equal to 0, and then we're going to solve each one of those. Okay? So let's get started. So if we have this first equation, notice we're already set equal to 0, so there's nothing to do there. We are going to factor this. So when I look at 16 and 41, I don't see a common factor. Although between v squared and v, I could take out a common v, leaving me with 16v minus 41 equals 0. Don't lose that equals 0 in your equation as you're working down your page because you're changing the value, so make sure you keep it there. Then we're going to take each of our factors. Notice we now have 2 factors. I have a factor v and I have a factor of 16v minus 41. So I'm going to take that factor of v and set it equal to 0. There's no work to do there. I'm done there. But with my 16v minus 41, when I set that equal to 0, I then now need to solve that. So I'm going to add 41 to both sides. And remember, we don't need to see that step. If you need to write it, go ahead and continue to write it. We'll have 16v, extra line. 16v is equal to 41. And then when we divide both sides by 16, we get v is equal to 41 over 16 and 0. Don't forget you have both of those answers, 41 over 16 and 0. Okay, so any of these steps, remember this step right here is not necessary unless you need to see it, and this step right here, you don't have to show us that. You can go straight from here to the answer if you need to. So if we move on to example 2, notice there's no common factor this time. And it is set equal to 0, so we're good to go. So no common factor. So we're going to go straight into our factoring our quadratic. So we're going to have factors of 7k, which would be 7k and k. Our factors of 4, Well, I typically would start off with 2 and 2, but since I'm trying to make a 3, notice when I do my double chin part, like we talked about the other day, this gives me 14K, and this gives me 2K. Well, 14 and 2 will never give me 3. And even if I switch the order of those, it doesn't change anything. So I would then choose not to use 2 and 2, and instead use my other factors of 4, which would be, which would be 4 and 1. So if I put my 4 here and I put my 1 there, notice 7K and 1 gives me 7K, 4K times 1 gives me 4K. Those will give me a 3, a negative 3, if my 7 is negative and my 4 is positive. So that helps me to go here and to here. So all that factoring that we've been doing the last couple of days has helped us to get ready for that. Now remember I mentioned earlier about writing this in pencil, so then you can easily erase that and nobody, not necessarily that they didn't know you did it, but it doesn't interfere now with the work that we're trying to do. Once we have our 2 factors, we're going to take each of those factors and set them equal to 0, and then solve each one. I could subtract my 4 over and have 7K is equal to negative 4. When I divide by my 7, I get K is equal to negative 4 over 7. Here, when I move my 1 over, I get K is equal to positive 1. I can write it together with just separating it with a comma, and that way my work is nice and neat. Notice we never lost our equal to 0, even when we set our 2 factors equal to 0. So, if we move on to number 3, again, we're already set equal to 0, so we're good to go. We look for a common factor. There is not one. So we're going to go into our quadratic equation factoring. So my factors of f squared would be f and f. My factors of 20, since I'm trying to equal 8, my factors of 20, we typically look at 4 and 5 because that's what comes to mind first. But notice 4 and 5 will never give me an 8. If I add them, I get 9. If I subtract, I get 1. So instead of 4 and 5, let's try using 10 and 2, because 10 times 2 gives me 20. And to get my 8, if I did this and got 2f, and I did this and got 10f, when I add or subtract those, in this case I need to subtract them, my 10 needs to be positive and my 2 needs to be negative. We can use our eraser, and then our work looks nice and neat. Now we can take our f plus 10, set it equal to 0, and our f minus 2, set it equal to 0, and solve each one. F is negative 10, f is 2. You can write them separate, or you can remember, put it as f equals and separate them with a comma. Either way you do it, it doesn't matter. Okay, a little bit more challenging. You look at a problem like this and you think, oh wow, those are some big numbers. What are we going to do now? So remember, same steps. Set equal to 0, we're already there, check. Look for our common factor. Well, between 3, 30, and 72, we have a common factor of 3. So factor out that 3. That helps to make things a little bit smaller. Whoops, that's a 10, not an 11. To make our numbers smaller when we're looking for our factors. So 3 goes into 72 24 times. Now we look at this and try to factor that farther, if it does. So do not lose the 3 that you pulled up front. We have our factors of k squared, which are k and k. Our factors of 24, which with 24, we have a 1 in the front, so we don't have to worry about having that extra factor. 24 that will give me 10. 24, we typically think of 6 and 4. Will 6 and 4 ever give me 10? Well, they will if they're both positive, and positive 6 times positive 4 gives me positive 24, so that's good. Now at this point, when we've got it equal to 0, and we set our factors equal to 0, this factor of 3, since it's just a constant number, it's not a variable, we can drop it now. All we have to do is set our x plus 6 equal to 0, and our k plus 4 equal to 0. So So it's not until you set your factors equal to 0, then you can drop that common factor of 3. You need to leave it there until then, because otherwise you've changed your values. Move your 6 over, and k gives you -6. Move your 4 over, and you get -4. So -6 and -4 would be our k values. Remember, you can always take those values and plug them back into your equation and check and make sure if they're right or not. Okay? For our last example for today, first thing we look for is everything equal to 0. It is not. So I would move because my v squared is negative, I would add my 7v squared to both sides and move everything over to the left, which means I'm also going to subtract my 49. Now when I write those, I'm going to write them in the order I like: 7v squared plus 42v minus 49 equal to 0, because these cancel now. And now again, start from the top. It said equal to 0. Factor it. Well, do I have a common factor? Yes. Just like a second ago, we're going to take out that 7. 7 goes into 42 6 times, and 7 goes into 49 7 times. Factor this farther if it goes farther. So b and b. Factors of 7, that will give me 6. Well, I only have 2 options, or 1 option for 7, which is 7 and 1. To get a positive 6, but I want a -7 here. A positive 6 and a -7. So my 7 needs to be plus, and my 1 needs to be minus. So that when I add them, I get a positive 6, and when I multiply them, I get a -7. All our factors, this one's a constant, so it's good. We can now drop it, and we're going to have b plus 7 equals 0, and b minus 1 equals 0. Move my 7 over, b is equal to -7. Move my 1 over, and b is equal to 1. -7 and 1. Okay, so hopefully that helps you see the reason that we've been working on the factoring the last couple of days, and why it was important when we were doing quadratics, and we told y'all how important it was that you were going to need it, because you needed it for solving. Next week we're going to start some rational functions, and we're going to have more factoring, which is why we reviewed it, and we're going to have some more solving also by the end of the week, and you're going to want to be able to solve those as well. Okay, so your IXL assignment for this lesson is A2, J for Algebra 2, J.8. J.8. And on these, you need to look for a SMART score of 90, so that you make sure you get to the types of problems that we need you to get to. If we left it at 80, you may not see some of the problems like these where you've got to move some stuff around. So this time we want to shoot for a SMART score of 90. Okay? So look on our websites, look on in your Google Classrooms, make sure that you're jumping on the Google Hangouts if you have questions. Reach out to your teachers if you have anything that you need to see. But for now, our third installment is complete. So good luck and take care, be safe, and wash your hands. Have a good day.